Hello everybody, welcome back. We're going to continue taking a look at the 2011 CSMC. So let's jump straight in and take a look at question number 5. If you're interested in any other questions, there are previous videos you can find on my channel for questions 1 through 4. So, question number 5. In the diagram, the circle has center O. OF is perpendicular to DC at F and is perpendicular to AB at E. If AB equals 8, DC equals 6, and EF equals 1, determine the radius of the circle. Okay. So, one thing I immediately notice is that, if a radius, which we can extend OF to a radius, if it perpendicularly bisects A and B, or the chord AB or DC, it splits them in half. Another way to see this is if we consider them with isosceles triangles. The altitude of an isosceles triangle splits the base in half. So let's draw ourselves a little bit of a picture here. O, we have A, B, we have C and D. We'll label F and E in there. So OAB and OCD are isosceles. So we can conclude that E and F are midpoints of AB and CD. Okay, so why is that helpful? Well, we know what AB is. It's 8. Now we know what AE is. It would be half of 8, which is 4. And we're starting to get a right angle triangle. I would suspect it's a 3, 4, 5 triangle, and my guess right now is that the radius is 5. And if I was cocky and overconfident, I might just put 5 and move on. But we're not quite done yet. We're actually going to work this out. Let's draw a bigger diagram now that we have some extra information. And we'll use special lines to denote the radii, so things are a little clearer. So you'll notice here in our diagram I've labeled x. Let x be the length OE. Well, OF is then OE plus EF. So we can see that that's x plus 1. Now triangles OEA and OFC and both of them have a hypotenuse of r. So we can get two equations for r using the Pythagorean theorem. So r squared is AE squared plus OE squared. Well, that's 4 squared plus x squared, or 16 plus x. Another equation for r squared would be CF squared, which we know is 3, plus OF squared. So 3 squared plus x plus 1 squared. So we have two equations and they both equal to r squared. That means we can set them equal to each other. Right? If two things are equal to the same thing, then they must themselves be equal. So 16 plus x squared is the same as 9 plus x squared plus 2x plus 1. Well, these x squareds will cancel out, and we can bring our numbers 9 and 1 over to the other side. So 16 minus 9 minus 1, that's 6, is equal to 2x. And that means that x is equal to 3. We want the radius. Well, the radius is 4 squared plus x squared. 4 squared plus 3 squared. So that's going to be 5 squared. This is a common Pythagorean triple. If you want to, you can work it out by calculator by hand. 16 plus 9, 25. 25 is 5 squared. So our earlier prediction was correct. R is indeed 5. And we just double check. Is that we were asked for? Determine the radius of the circle. Well, we absolutely got it. And if you're still not convinced, you could do a little check. You could work out, both of the triangles and see that they both do give a radius of 5 once you plug in x is equal to 3. But you don't need to do that. It's just the final answer style questions. It's not the written style questions. So everything we've done is basically for part marks. You just need to put a 5 in the answer. And that does it for question number 5. So we just have one more question to go in A part before we start getting to the dreaded written portion style parts of the 2011 CSMC. So please join me next time for question number 6. And if you liked this video, if you're liking the series so far, feel free to put a like on each of the videos that you've seen so far. But either way, I'll see you guys next time.